Hi everyone. Our DiffEq course is all about solving DiffEqs. So how are we going to know if something we found is in fact a solution to a particular DiffEq? Here I give you an example. How do I know if x to the power 3 is in fact a solution to this DiffEq? I just have to plug it in, actually. X cube, if it is a solution, we mean that y is x cube. Okay, so this is the first meaning. When I have a solution that I claim that I found, this function is y. And so in this case, I know y is x cube, so that I know y prime would be dy dx here in this particular equation, which is going to be 3x squared. So y prime prime would be d squared y dx squared, which is going to be 6x. And y prime prime prime, which will be also appear in our equation, it would be 6 then. So now we have all the ingredients, okay, so just plug it in. We are going to have 6 now as y prime prime prime, and then plus 2x cube times y prime prime is 6x, okay, and then minus 3x squared times y prime is actually 3x squared, and then minus 3x, y is x cube. Okay, so and then minus 6, and see if it is really 0. So I would plug in, I would say that left hand side equals to this guy, okay, and which is, let me just cross them out, okay, we have now 12x to the power 4 minus 9x to the power 4, and then minus 3x to the power 4, and we have 0, so it is actually 0 and equals to the right hand side. So now I have left hand side and the right hand side being balanced. It means that our x cube, y equals to x cube, is essentially a solution to the DiffEq. In this course, we are going to have a very common assumption for y. From time to time, we will say y equals to e to the power rt or e to the power rx. It depends on y as a function of t or y as a function of x. But now, since we defined y as e to the power rt, so that we would say that y is in fact a function of t then. Doesn't matter, still we are solving the equation. So here we would like to find the value of r when this e to the power rt would be a solution to the DiffEq that we are targeting. So in this case, we are still doing the same thing. When e to the power rt is a solution to the DiffEq, we are actually trying to put y prime and y prime prime respectively into the equation and check if the left hand side equals to the right hand side. So now we are going to do that. Y equals to e to the power rt, and in fact r is just a real value, okay, a real value. Okay, so now let's say that our y prime, so that I can take differentiation of e to the power rt with respect to t. Of course, we are doing dy dt now because y is a function of t. So take differentiation, I'm going to have r e to the power rt, right? On the other hand, y prime prime would be d squared y dt squared this time. Take differentiation of the first derivative again, we're going to get r squared e to the power rt. So now let's put all the ingredients into the equation. So I'm having r squared e to the power rt minus 2 times r e to the power rt, and then plus e to the power rt. And it has to be 0 because I want to see which value of r would be valid to give us a solution to the DiffEq. So in this case, I'm going to put the common factors together, which is r e to the power rt, and then I have everything else in the brackets. Okay, so in this case, I'm going to have either the first term e to the power rt or the second term, the brackets, equals to 0, so that the multiplication of them would be 0. So here, let's say that if e to the power rt is 0, then of course I have a solution. But the thing is, y is assumed to be e to the power rt. If I have e to the power rt equals to 0, I'm going to have a trivial solution. Okay, trivial means 0 here. Okay, or at the same time is trivial. It's not of the importance. Because why? We are solving DiffEq for the physical quantities. So if everything equals to 0, not that practical. So in that case, I'm going to set the bracket to be 0. Okay, so I'm going to have let r squared minus 2r plus 1 equals to 0. This is just a quadratic equation, so you can easily see that r equals to 1. Okay, and it is repeated. Doesn't matter, but now r equals to 1 in fact would give us a solution to the equation. Okay, so I would say that e to the power t is a solution. You may check it. Just put e to the power t as y. Okay, and then take differentiation y prime equals to e to the power t, y prime prime equals to e to the power t, and plug that into the equation, and you should be able to find the right hand side is 0. So this is 1, and we are going to take another challenge. We have another equation. We have an equation which is modified a bit. You can see that this is a second order ODE, linear, okay, but non-homogeneous because I have 2 as a g of x or g of t here. Okay, so now I want to find another r which would give our y equals to e to the power rt as a solution, okay, to this non-homogeneous DiffEq. So we're going to do the same thing. Now my y is e to the power rt, and you still remember y prime take differentiation. We're going to have r e to the power rt, and then y prime prime is r squared e to the power rt. And we still plug in to the equation so that we are going to have e to the power rt. Let me take out the common factors at the same time. So I have r squared minus 2r plus 1 on the left hand side, and this time on the right hand side I have 2. So I need to find out r. How about this? It might be more convenient if I can take a look on this equation by putting my brackets to the right hand side. Okay, so I have e to the power rt equals to 2 over r squared minus 2r plus 1. Don't worry, you may use other methods. That doesn't matter. You may put the e to the power rt onto the right hand side. But here you can see that very clearly. Why do I do that? Because one side has a function of t. Okay, but on the right hand side I do not have t. Okay, so this is very important that if I want to balance the both hand sides in order to find out r, I need to get rid of t then. How to? We have only one method, is to make the left hand side a constant. How about that? So I'm going to set r. How to make a constant? Get rid of t. The only chance, okay, would be I let r equals to 0. That would be the only chance, right? E to the power 0 would be 1, so that I can get rid of t. So in this case, I'm actually having the left hand side, okay, would be e to the power 0, which is 1. How about on the right hand side? Now I say r equals to 0, so I'm going to plug in 0 into the right hand side. So I have 2 over 0 minus 0 plus 1, which is 2. And of course, 1 is not equals to 2. So these two sides can never be balanced. Y equals to e to the power rt is in fact not a solution, okay, for any r. Okay,